CBSE Mathematics Class 12, Exercise 13.2, Question number 1. If probability of A is equal to 3 by 5 and the probability of B is 1 by 5, find the probability of A in intersection B if A and B are independent events. देखिए, if probability of A is equal to 3 by 5 and probability of B is 1 by 5, we have to find that the probability of A intersection B if A and B are independent events. By the multiplication rule of the probability we have, the probability A intersection B will be equal to probability of A into probability of B. See the page number, देखिए 543 of your textbook. You will get this formula. So just to put the formula here, write down the probability of A into probability of B. That will be equal to 3 by 5 into 1 by 5, and it will be equal to 3 by 25. And this is the required answer of question number 1. Now come to the question number 2. Two cards are drawn at random and without replacement from a pack of 52 playing cards. Find the probability that both the cards are black. अब देखिए, नंबर ऑफ ब्लैक कार्ड 26 होते हैं. Let the probability of A be the probability of getting a black card in the first draw. So the probability of A will be equal to 26 divided by 52. That will be equal to 1 by 2. And let probability of B be the probability of getting the black card on the second draw without replacement. So the probability of B will be equal to 25 by 51 because 26 में से 1 माइनस करेंगे 25 आ जाएगा, 52 में से 1 माइनस करेंगे तो 51 रह जाएगा. So thus the probability of getting both the cards black will be equal to 1 by 2 into 25 by 51. So it will be equal to 25 upon 102. And it is the required answer of question number 2. Now come to the question number 3. Question number 3 states that the box of oranges is inspected by examining 3 randomly selected oranges drawn without replacement. If all the 3 oranges are good, the box is approved for sale. Otherwise, it is rejected. Find the probability that a box containing 15 oranges, out of which 12 are good and 3 are bad ones, will be approved for sale. अब देखिए इस क्वेश्चन को कैसे करेंगे. देखिए कितने ऑरेंजेस है, 15 है, उसमें से 12 गुड है और 3 बैड है. लेट A, B and C be the respective events that the first, second and third oranges is good. First, let the probability of A is 12 by 15, being a good and not replaced. So the second, therefore, the probability of B will be 11 by 14, being good and not replaced. Third, probability of C, that is 10 by 13, being good and not replaced. Thus, the probability of getting all the oranges good will be equal to 12 upon 15 into 11 by 14 into 10 by 13. If solve it, we will get 44 by 91. Therefore, the probability that the box is approved for sale is 44 by 91. This is the required answer of question number 3. Second method for it, you can 12C3 means combination वाला फार्मूला लागू किया मैंने. 12C3 whole upon 15C3. So it will be equal to 12 factorial upon 3 factorial into 9 factorial whole divided by 15 factorial upon 3 factorial into 12 factorial. After solving, you will get the 44 by 91. This will be the required result. The same result can be worked out here with the combination formula. Now question number 4. A fair coin and an unbiased die are tossed. Let A and B, let A be the event, head appears on the coin, and B be the event, 3 on the die. Check whether A and B are independent events or not. अब देखिए, एक फेयर कॉइन है और एक है अनबियास्ड एंड अनबियास्ड डाई. बोथ आर टॉस्ड. अब इवेंट ए में क्या बता रहा है? हेड ऑन कॉइन. हेड कम्स ऑन कॉइन एंड 3. बी में बी इवेंट क्या है? 3 ऑन डाई. So therefore the sample space will be H1, H2, H3, H4, H5, H6. T1, T2, T3, T4, T5, T6. ये H stand for the head and T stand for tail. So these are the 12 elements. Let A such that the head appears on the coin. So the event A will be written here. H1, H2, H3, H4, H5, H6. So the probability of A will be equal to 6 by 12, that is 1 by 2. Now come to the event B. B such that 3 on die. Number 3 comes on the top of the die. So 3 on die. So H3 and T3. H3 and T3. These are the two elements. So the probability of B will be equal to 2 upon 12, that is 1 by 6. Therefore, the A intersection B will be equal to H3 and probability of A intersection B will be equal to, here element is only 1, that is H3, so 1 by 12. So probability of A into probability of B is equal to 1 by 2 into 1 by 6, that is 1 by 12. And you see the probability of A intersection B. A intersection B is also 1 by 12. Here we are getting that the product of probability A and probability B is equal to 1 by 12. Therefore, A and B are independent events because the probability of A intersection B is equal to probability of A into probability of B. That's all.